Hi, I'm JD, and what we're going to be doing today is a trig problem. Given the right triangle, find the 6 basic trig functions of theta, and theta is your given angle, and you have no clue what that is. So if you would, pause the video and see if you can try to do this one on your own. Alright, your first step always is to use Pythagorean theorem to find your missing side. So Pythagorean theorem is c squared equals a squared plus b squared, where c is your hypotenuse. Hypotenuse is always opposite of the right angle, and these are your legs, the other sides. So sum of the squares of the sides of the legs equals the square of the hypotenuse. So then you just plug the numbers in. So this is 7 squared equals 4 squared plus x squared. Then you just solve for x. So 7 squared is 49, 4 squared is 16, plus x squared. You solve for x, so you're going to get x squared all by itself first. 49 minus 16 is 33. So this is 33 equals x squared. Then next, to get rid of the square, you do the opposite, which is square rooting. So you square root both sides. So this would be square root of 33. And you would have a plus or minus here, but since you're dealing with a side is always positive. The length of it is. So this would just be x equals square root of 33. So I'm going to erase this so I have room for the 6 basic trig functions. Alright, next you want to do is just simply write out the trig functions. The trig functions is so, ka, toa, which means sine is the sine of theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Adjacent is the side that's right next to the angle. The side that's opposite of theta is the opposite, and your hypotenuse is always opposite of your right angle. So sine of theta is opposite over hypotenuse, so that's square root of 33 over 7. Cosine of theta is adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. So it's square root of 33 over 4. Next you have the reciprocal functions. So you have cosecant of theta. You take this and you flip it. So that's 7 over square root of 33. But let's say that they tell you to rationalize the denominator, and sometimes you'll see that in the back of the book, even if they don't tell you to do that. So you square root, you multiply the top and the bottom by square root of 33. By doing so, this square root of 33 times square root of 33 becomes 33 squared. You're taking the square root of that, so it undoes it. So it becomes 33, and this is just 7 square root of 33, because you can't simplify it. If you could, you would, but here you can't. Next is secant of theta. You take your cosine and you just flip it. Again, they're just reciprocal functions. So 7 over 4. Reciprocal just means you whoosh, flip the fraction. And so you're just whoosh, flipping the fraction. Now, tangents, the reciprocal function of tangent is cotangent of theta. So it flips it. So it's 4 over square root of 33. Now, again, because no one likes a radical in the denominator, you multiply the top and the bottom by square root of 33, like what you did here. And so you get 4 square root of 33 over 33. And that's it.